to find the mean, median, mode, and range of a set of data. So here you have some definitions. Those measures of central tendency are used to describe the middle of a data set. So median, mean, and mode are measures of central tendency. So just kind of a quick review. Mean, to find the mean or the average, you add the values in the data set and then divide by the number of values in the set. This is good to use when your data doesn't have any outliers that would really impact that average. Median is the middle value or the mean of the two middle values in an ordered set of data. Use again when the data doesn't have outliers. The mode, the value that occurs most frequently. A data set may have no mode, one mode, or several modes. And then range, that's the difference between the least and the greatest values in a data set. This is when you want to see the spread of the data. All right, so first thing we're going to look at is outlier. An outlier is a value that is either far less than or far greater than the rest of the values in the data. Sometimes we talked about this when we were thinking about which one doesn't belong. So imagine if you generally get 90% or higher on all your math assignments, and then one time you get 60%, that would be an outlier. That's far outside what your typical grades usually are. All right, we're going to find the mean, median, and mode for this set of data. So the first thing, to find the mean, we have to add all the values. So I've already added those together. All 7 of these values equal 189. Then I'm going to divide by the number of values, 7. And so the mean, the average for this set, is 27. The median, again, is that middle number. So if we put these in order, it would look like this: 21, 21, 28, 28, 29, 30, 32. I like to just kind of cross off from the edges, and the median is 28. The mode, that's what occurs most frequently. In this set of data, we have two 21s and two 28s, so we actually have 2 modes for this. The range comes from taking the largest value, in this case it's 32, and subtracting it from the smallest value, which is 21, so the range is 11. All right, again, finding the mean, median, mode. So for this set, mean, again, we need to add up all the values and then divide by the number of values. So these values together equal 259. Again, there are 7 values. That means my mean is 37. And you always want to think, okay, does that make sense for the numbers? Yeah, 37 kind of fits into that group. The median, again, if I put these in numbers in order from least to greatest and found the middle value is also 37. And then for the mode, this is the one that occurs most often. And you can see up here there are 2 37s and there are 2 45s. So again, we have 2 modes for this set of data. And then the range comes from taking the highest value, so 45, minus the lowest value, 22, and we come up with the range being 23. All right, determine and find the most appropriate measure of central tendency or range for each situation. Justify your answer. So it's going to tell us what we're going to figure out for this. So competitors receive the following scores for their performance in a gymnastics competition, and there's all those scores listed. Which score occurred most often? So first we're being asked to find the mode. What occurred the most often? So when we look at these scores, I can see that I have, let's get a highlighter up with a better color. There we go. 1, 2, 3 9s. That's the only value that occurs 3 times, so the mode is 9 for this problem. All right. The number of students in an 8th grade science class in 8th grade science classes are 20, 25, 23, 24, and 27. What number best describes the middle of these classes? So we're trying to find middle, which means median. So I'm going to put the numbers in order: 20, 23, 24, 25, 27, and here is my median, my middle number. All right, the ages of parents of the 8th grade class are 37, 39, 35, 44, 40, 40, 39, 34, 49, 41, and 42. What number best describes the average age, which is also the mean? So when we add these together, we get 440. There are 11 values, so that's what we're going to divide our total by, and the mean or average is 40. All right. Again, here's our question. 12 children stood in line at a movie theater. Their ages were the following: 7, 9, 11, 12, 11, 10, 13, 11, 8, 7, 9, 11, 8. Which age occurred most often? So we're looking for the mode. When I look at this set of data, it looks like I have 1, 2, 3 that are 11. So the mode is 11. All right, how much impact does removing a data point from a data set have on its mean and median? So just for you to think about, so if we have something that we remove from a set, if the value is an outlier, the value will have a great impact on the mean. So again, thinking back to that scoring, so imagine if you always get 90% or higher on your assignments, and then you have one lower score, maybe in the 60s. If your teacher was nice and said, you can throw out your lowest score, that outlier throwing out that outlier would have a very great impact on your average. If that was just another 90-something% that you threw out, it wouldn't have much impact on the mean. If the data value is not an outlier, the value will have minimal impact on both the mean and the median. So if it's an outlier, it's going to have a pretty great impact on both the mean, the average, and the median, the middle number. If it's not an outlier, it will have minimal impact on that. All right, so we're going to look at that. So it says identify the quiz score that is an outlier from this dot plot. So you can see right here, our outlier is 20. And so we're going to calculate the mean quiz score and the median with the outlier, and then we're going to do it without the outlier to see what happens to our numbers. So the mean with the outlier, if I add up all the scores, I end up with 2,000. And there are 25 scores, so my average score comes out to be 80. The median, it's easy to see. If we count from the edges, the median ends up to be 80 as well. Okay, so now if I want to find the mean without the outlier, what I would do is I would take my total, and then I'm going to subtract that 20. And then I'm going to take my 25 scores, I'm going to subtract 1. So this time I have 1,980 being divided by 24 scores. And you can see the average, the mean, goes up because now we have that low score that's been taken out. In this case, the median stays the same. It's still 80. So which measure was affected more by deleting the outlier? The mean was affected. If you remember, the median actually stayed the same. And then it says, suppose the student takes another quiz getting a score of 70. Find the mean and the median of the original data with the added quiz score. So to do that, we know that our original total was 2,000, and now we had one more score, that's 70. And we originally had 25, so we're going to add one more. We end up with 2,070 divided by 26. This average comes out to be about 79.6. The median in this case, if we added that one extra value, still will equal 80.